So we had derived already last time on 38, we had derived that yes, if you have this is yes, so this is diagram must be drawn neatly. So an element and a wedge has been cut out of a rectangular element. This is a wedge, you have put this one, and this wedge also is in a state of equilibrium. Only thing is that this one is your x and this is your original y, and now this is x dash, a new, and this is your y dash. Which angle is theta? We have taken which angle theta? This one angle is theta? Huh? So this is theta, so this one is how much? Theta. Okay, so this is the status, and we derived, yes, there is a relationship that we can derive, that sigma x dash is sigma x plus sigma y by 2 plus sigma x minus sigma y by 2. It is written in 2 theta form, cosine 2 theta plus tau xy sine. So knowing these quantities on the right hand side, you can find out the value of this on an inclined plane. What is the meaning of this? And similarly, you can also find out what is the other one. I don't want to derive. Can somebody tell me what will be the value of tau x dash y dash? Anyone quickly? Otherwise, I will have to look up the book. I have forgotten. So I will have to look up the book. Anybody? You did not open, huh? Yes. Yes. Sigma x minus sigma y by 2. Yes.
Plus tau xy cos 2
plus tau xy. Very good. Yes, this is right. So this part is not there. This is not there in shear. When you find out the value of shear, that means when you sum all the forces, what was ABCD? We had. I think we had named something ABCD. I don't know. AB. This is A. This is B, and this one is C. This is theta. Yes, everything is okay. So this is the, yes. And please remember, don't make the mistake, stress quantity is not a force. Stress has always to be converted into force in order to write down the equilibrium conditions. So force will be this length multiplied by the width. Width we have taken unity. It can be anything. It can be also dz. You can take dz also, some slice. So anything will do, it will be same result will come. So on the width it is, and then we have assumed here state of plane stress. You must know what is the meaning of plane stress. Plane stress state means See, I don't want, see, even after doing PhD, people do not know correctly. Okay, so I want you to understand this concept of plane stress. That is, out of 6 components, if it is, the loading is such and the body configuration is such, that means Z dimension is very, very small. There are 2 things. One is loading is in the plane XY, all loading, and Z is very thin compared to X and Y. Then only state of plane stress can occur. And in that case, these stresses, any stress on Z equal to constant plane, what are the stresses? Sigma Z, tau Zx and tau Zy. All these 3 will be 0. So don't start with strain and tell plane stress, so sir, this will become thin, so this strain will become 0. Don't utter the word strain when you are defining plane stress. Plane stress, you say that this will be 0, and then you are left only with the remaining 3, and remaining 3 are shown here, tau sigma x, sigma y and tau xy. Is it okay? So this is called plane stress. So we are deriving this for state of plane stress. You should also know how to derive the Hooke's law for plane stress. I think I have already told you. Hooke's law for plane stress, you should know how to derive it. And okay, now when I make this angle, see, this is theta equal to, supposing I make theta equal to theta plus 90. Let this is 31. So let theta equal to theta plus 90. Change theta to theta plus 90. What is the meaning of this 90 degrees, or theta plus pi by 2 in radians? So that means we are talking of, this is the inclined plane, and this direction is x dash. When it is theta plus 90, so this is already theta, add 90 to this, that means this one 90. So we are talking of this plane. So when it is theta plus 90, we are talking of this plane perpendicular to, when theta becomes theta plus 90. So we are talking of, this is your y dash. So you will get here on this plane, which is perpendicular to this, which is perpendicular to this. Do you understand this? Now the element is inclined. Element is making this plane is making an angle theta with horizontal. So it is inclined. So theta plus 90 means this 90 degree up to here, and so therefore this one will take the position of sigma y dash, and your tau x dash y dash, and then tau x dash y dash what will happen? What will be tau? Tau will, on this plane, the positive tau will be, if y is, but this is a positive plane as far as y is concerned, y dash is concerned, so this is a positive. So the shear positive will be, this is tau y dash x dash. So then that means substitute in the same formula, sigma x dash at theta plus pi by 2. So that will mean, that will be the meaning of sigma y dash, that is equal to sigma y dash, and that will become sigma x plus sigma y by 2, no change because there is no angle here, plus sigma x minus sigma y by 2 into cosine 2 theta. So cosine theta plus 90, so 180 plus 2 theta, 180 plus 2 theta, it becomes so that is why pi, let me first write down, this means theta plus, I am substituting theta equal to theta plus 90, so it will become pi plus 2 theta, let it be full form, and then plus tau xy sine again 2 theta, so it will become pi plus 2 theta. So please tell me what is the value. Now it will become sigma x plus sigma y by 2 plus, no, this will become pi plus 2 theta is what? Sine or cosine? Which quadrant? Third quadrant. Yes. This is in, so this is ACTS. Yes, pi plus theta. So here cosine tangent is positive, so negative. See, do you know this, by the way, what I have written? What is it? No. It is called acts, ACTS. Acts clockwise. You start from the first quadrant. This is first quadrant, this is second quadrant, this is third quadrant, and this one is fourth quadrant. So acts ACTS clockwise, it is acts ACTS. So A all positive, C means cosine positive, T means tangent positive, here sine positive. I don't know, I mean whether, but that is how I learnt it, you know. It is the other way? Achha, okay. Anyway, you remember the way, I mean, my teacher told me that it is ACTS. Remember this? So that is how I remember. So this becomes how much? Minus what? Cosine only, na? Cos only. Plus, again minus. Sine also will become minus. Yes, sine also is minus. So this also is minus tau xy, I hope, into sine. You have to remember. So this is, so you got y dash, and similarly tau x dash y dash or tau y dash x dash, you know, both are equal. This one, this one, which is same as this, they are complementary to each other, and that at theta plus pi by 2 will become equal to tau x dash y dash, and that one will become this one. So pi plus 2 theta. Sine is negative, so minus again. So minus and then again cosine. This is cosine, so cosine also is minus. Some garbage is there? Tau y dash x dash or x dash y dash both are equal. That is same as equal to this, na? Complementary. Shear. Here. I don't find any change, anything wrong. This is okay or not, right hand side? Then? Oh, theta. Oh. Theta plus. Okay, not equal to. This is plus. All right. So this is. So now, what you should remember is this. What you should remember is this, that now see my element has become like this. At the same point I have changed the orientation. Whatever that rectangular element was there, I have changed the orientation, and originally it was, let me draw the original I will draw a smaller. Originally at the same point I was showing my, so this was sigma x, this was sigma y, and this was tau, and this is tau at the same point P. Now after transformation, these have become sigma x dash. At the same point, we are just rotating the element. I have only expanded the element here just for your sake, just to explain. I have expanded. At the same point, so now the stress on these planes are different, but they are related to my original. So if you rotate this element at the same point, you will find a different configuration, different direction. This on the normal planes, the stresses will go on changing. But don't think that it is the stress at the same point. Only thing, now it is being referred to a different set of axes. So stress is a quantity which is not only has magnitude and direction, but it also depends upon the plane on which it is acting. So stress, and that is why such a quantity is called tensor. So it is a tensor, second order tensor. So stress is a bigger quantity, it's a more complicated quantity, because there is an element, that is a plane is coming in the picture. It is not only direction and magnitude in x direction, y direction, but it also depends upon whether you have drawn this plane or that plane. So it will be depending on that. So it is a tensor, and tensor, this is a second order tensor. I will not second order tensor, and we are talking of Cartesian tensor. So tensors have their own transformation rules. Tensors have their own transformation rule, and this is the transformation rule for tensor. We have derived one transformation rule for tensor, is this. Yes, I can find out this quantity by this transformation rule. The reason is x dash y dash is coming negative of this, because this previous one, this one, This one.
This one is negative of control as theta. Should be here.
So what? But it will depend upon theta. No, see, it has no, see, this x dash y dash is occurring, this we are talking of on this plane, this one. This is negative of this, very correctly, because this is acting in this direction. Supposing I make theta equal to 0, so this is you know, this one is acting upwards, and this is, I mean,
And the magnitude is negative. Downwards.
no. See, there is always the shear stresses always, see, shear stresses will always be like this at any.
Yes.
So we will call, if this is positive, so this one will be negative. Shear stress, when it comes to direction, because if I will align this to vertical, let us say I align this to this one to vertical, so this is upwards, y direction. Now if I align this to vertical, no. If I align this to vertical, it is like this. So if this is aligned to vertical, yes, one is negative of the other. See,
It is in positive y direction, and it is in, if we take in
theta equal to 0.
Sir, it's correct, sir. If you take sigma x, that you rotate it by 90 degrees,
Nine.
that vector over there. Similarly, if you rotate now x dash y dash, this will be the direction. And we are reaching the direction that we are getting negative. That arrow will be downward, sir. That arrow will be downward.
Which arrow should be? Which arrow should be downwards?
Now y dash direction.
Huh?
Now y dash direction. Yes, sir. That arrow will be downward.
This one?
Yes, sir.
According
to your convention.
How can it be? See, this is a positive plane. This is a positive y dash plane. So on a positive y plane, my shear stress is positive, like this.
But you're orienting it, but you're basically rotating that plane by 90 degrees, right? Yes, sir. If we rotate that plane by 90 degrees, then tau x dash y dash will become fixed. Tau y dash is fixed.
Anyway, you think about it. Which one? This one?
And if you are drawing in this direction, you have to take one negative.
No, I will not accept. Okay. This arrow is right. Both the arrows are correct. And so anyway, we'll take it up. You think about it. Okay, so at the same point, the basic idea is that the same point now we have got, so this is the transformation rule for stresses. Stress follows one transformation rule, and which is not same as vector transformation rule. So this can be written by this. So this one you should know. So now once you are rotating, what happens once you are rotating at the same point, there is one direction, go on. What will happen? You will find that this normal stress on this plane is going on increasing. There is some shear stress. There is one direction when the normal stress on this plane, there will be only one normal stress. So supposing no shear stress. So is there any possibility that for some value of theta there will be no shear stress here? Yes, that you can find out. We can find out that yes, derivative of this quantity with respect to theta and see whether that is equal to 0, and maximize that and see, and then substitute that value of theta in tau x dash y dash, and if it comes out to be 0, then so there will be one direction here. Let us say there is one direction, and that direction, that means I am rotating now at the same point, this element. This direction I am calling it 1, and this as 2. Now for this particular 1 and 2 direction, I find that here on this plane, so this one will be, if it is one direction, this will be sigma 1 and this will be sigma 2. So you will find, of course, sigma 1 and sigma 2 will be different, but then what happens that there is one direction 1 for a particular value, for a particular theta, for a particular theta, when theta equal to becomes, let us say theta 1, I will call this theta equal to theta 1. We don't know some theta 1. Is it okay? Theta equal to theta 1. Then I find that sigma x dash equal to sigma 1 and tau x dash y dash equal to 0. And then I find that this happens to be, you go on rotating by 2 pi, full circle, this element. You will find there will be only one direction for which this happens. This one will be, this tau x dash becomes 0, no shear stress here. On this plane, the shear stress turns out to be 0. We can prove it mathematically, but first understand physics, because this set is changing. These two values are changing as I am rotating. Don't worry about this direction, y dash direction. Let us take only x dash direction. The set sigma x and x dash and tau x dash y dash, they are changing with respect to theta. So you plot that and you will find that yes, for one value, when it becomes theta 1, it is becoming sigma 1, and then this is becoming 0. Then you will also see that this happens to be sigma maximum. And then what about this? Because on the right plane there will be sigma 2, and sigma 2, that means sigma y dash, which will be equal to sigma 2, that will become sigma minimum. Shear stress 0 on both these planes, because if it is 0 here, it has to be 0 here. Why they have to be 0 here? If it is 0 here, then it has to be 0 here. Yes, complementary to each other. Shear stress complementary. So if this exists, this must exist. If this is not existing, this also should not exist. So shear stress 0. Now this one direction is called principal direction. Principal direction. And this plane and the plane corresponding to direction 1 is called principal plane, not PLE. I think principal important. Can it come? No, it is principal. So this is the principal plane. This one is principal direction, and on a principal plane, the shear stress is always 0, and the normal stress is always maximum. Then what is this plane called? if this is principal plane, if this is maximum and here it is minimum, right angle, I don't know, plus minus, because one is which is the plane at 90 degree, because then this turns out to be minimum. See, if you are rotating, you may hit first this one in such a way that this will become minimum and then this will become maximum, because one will be minimum, other one will be maximum. So it is not that this will always be x dash, only has to be only, in fact x dash only becomes y dash. So it can be this minimum or this maximum, and vice versa here also. So the plane on which I will only say the plane on which sigma normal is maximum is called principal plane. The other plane, please find out from the book, I have forgotten what it is called. This direction is principal, it is a complementary, or I would like to say only one. This plane is principal direction and this plane is principal plane. Now this stress is very important. That means what is most important in this, in understanding, that you start at the same point with some state of stress when this is sigma x and see, even after I am explaining this much, all the directions, I will find in the notebook when the examination, some people will be drawing clockwise all shear stresses. There will be some people. Some persons will be writing, showing all same direction. Okay, so don't do that mistake. So this gets transformed into a one sigma 1, sigma 2, sigma 1, that is all, nothing else, no shear stress. So this direction is principal direction. Now something is also happening to the shear stress. Shear stress also must be becoming smaller or bigger if you plot it with respect to theta. That means it's a question of plotting sigma x dash with respect to theta and tau x dash y dash with respect to theta. You please plot. You will find that this, I don't know, something happens. There is one, so this value of theta, it is maximum, and this value of theta, shear stress should come out to be 0. So if the angle is shear, so shear stress must be 0 here, something. I don't know. I mean, at least here shear stress for the same value of theta. This theta is same, so this theta equal to theta 1 here, and this is general theta. This is general theta, and this one theta 1. Theta 1 shear stress must come out to be 0. So I will have some variation. Is it okay? So this is one. You please plot. So shear stress also will have a plus or minus. And not only. And please and see, not that this diagram is 100% correct. This may also go in negative. Yes, this is not 100% correct. I have just given you a very qualitative picture. Okay, but idea is that yes, there will be some variation here, and this will be some variation here, and this will be, and there will be one. I will stop there after drawing that fifth. There will be one direction which we'll call here, you will find that shear stress here is becoming maximum. I will give it 1 dash. So this is 1 dash and this is 2 dash. So here I will call this. Then you will say, why this normal stress is there? Yes, it so happens that tau, so for some value of theta equal to theta 1 dash, tau x dash y dash is equal to tau 1 dash, and that is tau maximum. But then here the normal stress is not 0 on such a plane. On that plane, 1 dash plane, normal stress is not 0. This we will still call, yes, there will be some normal stress here, 1, not 0. This can be proved mathematically. And how will you prove this? You please find out, you have got the expression of x dash y dash with respect to theta. Find out the maximum value. Differentiate that expression with respect to theta. Find out what is the value of theta for which it is becoming. So please do that. And when you come to the next class, I want that expression from you. What are the angles for which normal stress is maximum and shear stress is maximum? Now this plane again is called plane of maximum shear stress. It is not called principal plane. Principal plane is only that plane on which normal stress is maximum.